chose to model our parts in Fusion 360 because of the background we have in this software and the ability to easily transfer it to a 3D printer. We built each part separately for our front steering and then assembled it in the software to ensure correct dimensions and feasibility before 3D printing parts. We did some research on common steering in RC cars and came up with a similar design that would fit inside our constraints. The steering will be done by a servo motor that is connected to the pitman arm that then connects to the sway arm and onto one wheel. The servo motor will then push or pull on the pitman arm to turn the wheels left or right. We built the prototype out of 3D printed parts, a small piece of wood, and 3.5 bolts and nuts and zip ties. We assembled the front steering parts and attached the servo on the piece of wood into the pitman arm. We then connected the back motors to the wood using zip ties and attached the wheels straight onto those motor shafts. We also added on rubber bands for added traction until we get our actual tires.
Our app communicates to the Raspberry Pi through a port in the wireless network. To demonstrate this, we'll first SSH into the Raspberry Pi and go to the directory where our files are. And then we'll run our script. So it's communicating over port 55638. We're using an app simulator just for demonstration purposes of this video. And when you hold the button, it'll move the vehicle until you let go of the button. So for forward, keeps going, stops when the button's released, and same for all the other buttons.
For us, system integration was the most difficult part of Prototype 1. Despite detailed designs and plans for each discipline, putting the system together required skills beyond our current set. Because our group does not have an electrical engineer, we had to figure out the wiring ourselves. We were given this diagram. We attempted to make all the same connections on our car, but found trouble. Unfortunately, the diagram gave recommendations for a speed controller that worked with only one motor. As previously shown, our vehicle has two. Beyond that, fitting the system together was a challenge. The wires attached to the battery we picked did not match those on the Raspberry Pi. Our mistake was in the focus on our individual assignments, since we did not have the discipline that linked the two together. Despite having a sturdy prototype vehicle structure and a dependable control app, the car has yet to move forward or backwards. As soon as the wiring is figured out, it will be ready. But without the previous knowledge, our team is taking a bit longer to get there. We are confident in our design because of the rigorous testing. The control app was tested on home as well as school Wi-Fi. We tried it on different phones using a virtual emulator. Additionally, we connected the Pi to an LED and got that to turn on and off, something with simple wiring that showed the same principle as the car will. For the car, we tested durability and movement by hand, ensuring the wheels spun, the steering mechanism allows for turning, etc. At one point, the prototype was pushed up a hill to test traction, and we found that adding a rubber band to the wheel was necessary while we waited for the actual tires.